Let me read the question now. Table 1 shows the values of two variables x and y obtained from an experiment. The variables x and y are related by the equation y plus square root h equals to k square divided with x, where h and k are constants. So this is the table, consists of x and y. Okay, so the question asks to plot xy against x using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 0.5 unit on the xy axis. Hence draw the line of best fit. Okay, this is for the part A, where they ask us to plot the graph. Okay, for the question part B, by using the graph in question 10a, find the value of x when y square equals to 4 over x square, and write y plus square root h equals to k square over x in linear form. Hence find the value of h and of k. Okay, so this is the overall question. So from here, let us begin our discussion for the question 10 part A. Okay, so from here, for the question 10 part A, we are required to plot the graph of xy versus x. So by the way, I have already made the table over here, so let me paste this. Okay, so this is the table for our reference. Okay, in the first table, the first row over here, you can check that it's in the x-axis. The second row consists the y-axis, and the third one is consists the xy axis. Okay, so from here we have the data regarding x, y, and x. So from here we can do the plotting the graph. Okay, by follow the scale given by the question. Okay, by the way, I've already completed the graph for you, so I'm going to show you how the graph looks like. Okay, so let me set it to full screen. So this is how the graph looks like. Okay, this is the graph of xy against x, where I've already formed the line of best fit over here. Okay, as you can see here, one point and another point didn't touch another, so it's literally balancing the graph. So this is considered the line of best fit. Okay, so whenever you're dealing with a linear log question, remember that your answer might not be exactly same as the answer scheme. Okay, you might be doing the linear log graph and you might do the sketching, but then whenever you check the answer, you might not be getting the 100% same. You not get exactly the same, you might be a little bit close, somewhere around there, but it's okay. Okay, so from here, so this is your graph, and this is how it should looks like. Okay, so from here, let me scroll this down and proceed our discussion for the question part B. Okay, so from the question part B, we are required to find the expression of y square equals to 4 over x square from the graph that we have plotted. Okay, so from here, y square is equals to 4 over x square. Okay, so from here, what you're going to do is this x square, we're going to times with y square, or we're going to times x square both sides. So from here, you're only left with x square, y square is equals to 4. Okay, so this x square, y square, we can factor them out. We can group them as x, y square is equals to 4. Okay, so from here, since we have the xy axis over here, and we have xy square is equals to 4, so we can square root xy. So from here, you square root xy, you get 2. Okay, so from here, xy is equals to 2. Now what you need to do is, in the graph, you need to check which xy value is equals to 2, and then you need to interpolate and pull down at the x-axis, and from there you need to check which value corresponds to the xy equals to 2. Okay, so from here, let me show you. Okay, so this is the xy value is equals to 2.0. So let me zoom in. Okay, zoom in. Okay, so this is the xy is equals to 2. So what I did is, I extrapolate until it intersect the graph, and then I pull down over here. Okay, when I pull it down, it's actually intersecting at 2.7. Okay, so this is the place of intersection. Okay, when your x y equals to 2, so from here you get your x is equals to 2.7. Okay, so this is the simple explanation. Okay, like I said, for this type of question, your answer might not be exactly same as the answer scheme. Okay, So from graph, when xy equals to 2, so from here you get your x is equals to 2.7. Okay, so let me underline the solution for the question part B. Okay, so we're done with the question part B. So let us proceed our discussion. Actually, this is question B part 1. And now you proceed our discussion to the question B part 2. Okay, for the question B part 2, we are required to change the non-linear into a linear form. Okay, usually this will be the first step, but surprisingly this working is towards the last step, but it's okay. Usually what the question they will do is they will give you an expression, and from there from non-linear expression they change it, you are required to change into a linear form, and from there only you need to come up with a table form. But this question is the other way around. Okay, you plot the graph, and from there only you are required to do this step by changing from non-linear form into linear form. Okay, no problem, we will do it together. Okay, so from here let us write the non-linear equations. Y plus with square root h is equals to k square over x. Okay, so from here what I'm going to do is I'm going to times the whole equation by x. Okay, so from here you get xy plus with x square root h is equals to k square. Okay, and now what I'm going to do is I'm going to arrange it such a way that it fulfills the straight line equation where y equals to mx plus c. Okay, so from here this xy we're going to treat it as y, so xy will be equals to, okay, so this x square root h from the left hand side we're going to move it over to the right hand side. So from here you get is negative x square root h plus with k square okay. So we change this equation, modify a bit. So from here xy is equals to negative square root h, okay, in a bracket x plus with k square. Okay, so from here this xy is representing as the y. Okay, this negative square root h is representing as the gradient of the straight line. Okay, this is representing as the x. Okay, and the y-intercept is representing as k square. Okay, so this is the linear equation, I mean non-linear to linear form, guys. Okay, so from here, since we have already plot the graph, okay, and we can check here you have a negative gradient, and it is proven that you have here the negative slope. Okay, so it is proven that your xy versus x is actually correct. Okay, so from here the first step what you're going to do is, okay, we're going to find the value of the h. So how are you going to find the value of h? We're going to calculate the gradient of the straight line. Okay, so how to find the gradient? So from here what I do is, okay, let me set the full screen again. Okay, zoom in. Okay, so I just take any random 2 points. Okay, from here I choose the 2 point. Okay, the first point I choose is the coordinate 2.7 comma 2.0, and then the second point is over here, which is 3.35 comma 1.5. okay, I choose this. Okay, if you look closely, it's actually intersecting at 3.35, 3.1, 3.2, 3.3. okay, and then you have 3.35 over here. Okay, so from here I choose 2 points, and from there I calculate the gradient. So how to calculate the gradient? Okay, basically is y2 minus y1 divided with x2 minus x1. Okay, the same concept you apply over here. Okay, so from here m is equals to, okay, so which one you want to choose, y2, which one you choose y1, okay, it's up to you. Okay, so from here 2.0, okay, and then you minus with 1.5, okay, and then divide with x2, 2.7 minus with 3.35. okay, so you calculate this. So from here you get your m approximately negative 0.77. Okay, if you check in the answer scheme, you should get your gradient is equals to negative 3 over 4, but then we get here negative 0.77. okay, negative 3 over 4 indicates that it is negative 0.75 when you convert it into decimal, but here we get negative 0.77. that's why I told you your answer might not be exactly the same when you're doing it in real as compared to the answer scheme, but just by a difference, a very small difference, it is acceptable. Okay, so from here let me underline this. Okay, so from here we're going to compare this value with the negative square root h over here. Okay, so from here m, okay, is equals to negative square root h. Okay, so from here negative square root h is equals to negative 0.77. okay, so from here the negative and negative will get cancelled off, and then you're left with 0.77. okay, so to get h, what you do, you square both sides. So from here you get your h is equals approximately 0.593. okay, so let me underline the solution. Okay, this is the first answer. Alright, okay, so this is your h. Okay, let us focus on the next value, which is the k. Okay, so in this case the variable k square is related to y-intercept. Okay, let us open our graph here, but before that let me write the relation c is equals to k square. Okay, let me open the graph again. Okay, set to full screen, zoom in. Okay, so from here if we check, it's actually intersecting at 4.1, but if you check in the answer scheme, some of the answer scheme book, the graph will be intersecting at 4, but over here we are intersecting at 4.1. it is acceptable, guys. By the way, a small difference, it is acceptable within plus minus 0. Plus minus, I think certain values it is acceptable, but let's say if your answer scheme is 4, you get 5.0, then something is wrong. Okay, that means that is totally a wrong answer, but if you have a minor difference, then it is acceptable. Okay, for us, we follow what we do. Okay, from this graph we get 4.1. okay, c equals to k square, and from the graph k square we get equals to 4.1. okay, so from here to get the k, what you do, you square root 4.1. okay, and from here you should get your k approximately approximately 2.02. okay, let me underline this. Okay, so let me scroll up. Okay, so that is all. We have come to the end of our discussion for the question 10 SPM 2021 Add Maths paper 2. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.